percent increase, decrease. So we have a formula we can follow. So we have a percent, say, change, which is equal to our new value minus the old value over the old value. And then that's going to be multiplied by 100%. Now, if there is, right, if it becomes positive as the end result, then we see an increase. But if this percent change is negative, then it is a decrease. So let's go ahead and look at the first example. So a hospital had 12 babies delivered in 1 week. The next week, the hospital had 22 babies delivered. What is the percent increase in the number of babies being delivered? So if we're looking at this, right, the new value then, so we're going to go percent change, and I'm just going to go NV minus old value over old value, because it's just a little bit easier to type it, or to write it faster. So our new value is going to be the 22. Our old value was the 12. So now we can go ahead and fill that in. So we have 22 minus 12 over 12 times 100. So 22 minus 12, well, that would be 10, and that's over 12 times 100. So what would that be equal to? So let's get a calculator. And we get 83, and then it just continues on, 0.333. So let's just go ahead and go 83.3, we'll just round to the nearest 10th percent. So that would be the percent change. Now notice that this is positive, so that's good, because if it's positive, then that means an increase, and we were looking for a percent increase, right? Because it went from 12 to 22. So we know we did that correct. So let's go ahead and look at the next example. Example 2. A hospital had 17 babies delivered in 1 week. The next week, the hospital had 5 babies delivered. What is the percent decrease in the number of babies being delivered? So once again, we have the percent, right, change, and we have the new value minus old value over old value times 100%. Now our new value is going to be this 5 babies, because that's the second week. Then our first week is our old value. So let's go ahead and fill this in. So we have 5 minus 17 over 17 times 100%. So we can just get our calculators out, right, and go 5 minus 17, that's negative 12, over 17 times by, just by 100%, and we get, negative 70 point, and we'll just round to the nearest tenth, so 0.6. So 70.6. And so this would be percent. Now we don't want to represent this as a negative 70.6%. We'll actually still represent it as 70.6%. So this is our percent change, and we know it was a decrease because it was negative, but we're just going to say 70.6%. We'll drop that negative, and that's a good indicator because we were looking for a decrease. So having a negative at the end is always a good sign. Example 3. A hospital saw a 40% increase in number of babies being delivered from 1 week to the next. If the first week there were 20 babies delivered, how many babies were delivered the following week? So we have percent change, which is equal to our new value minus old value over old value, right? Just old value times 100%. So if we look at this, right, we see we actually have the 40% increase. We actually have the percent change. Then we have in the first week, so that would indicate to us that that would be the old value. So that looks like we're looking for our new value. So let's go ahead and start to solve. So 40%, right? Right, we can just go 40%. New value, so that would be x, then minus 20 over 20 times 100%. Now, if we wanted to go ahead and get rid of, right, this 20 and this 100, so we can start getting this x minus 20 all by itself, right, we can just go ahead and take the reciprocal, right, of this 100 and then put the 20 on top. So why does that work out? Because we have 40%, just to show this a little bit better. So that's really what this looks like, right? And so we can just get rid of these by taking the reciprocal, right? This crosses out. That's just 1. That just becomes 1. You have to do it to the other side. Notice now these percentages cross out, which is good because we want just a number, not a percent. So we have 20 times 40 divided by 100, which is equal to x minus 20, right? Because being multiplied by 1 doesn't change any of this because that still becomes a 1, right? If we did distributive property, and that's still minus 20. Now 20 times 40, let's get our calculator, divided by 100, and we get 8. So we have 8, which is equal to x minus 20. Then to get x by itself, we go ahead and add 20 on both sides. And we're given x is equal to 28. So there's 28 babies being delivered the second week, right? Now, if you're not sure if that's the right answer, we can go back, right, and plug this in here. Right, so we can just do this real quick. So 28 minus 20 divided by 20 times 100 gets us 40. So that would be, and it's also positive, and this is a percent increase. So we know we did that right? Look, we just go check our answers. So always know you can go back and check your answers.